doing limit composition. So we are finding the limit of something, but not just one function. If it just says find the limit of f or find the limit of g, that's pretty easy. It's when you start adding limits together, like taking f plus g, or taking f times g, or f divided by g, or a composition, f of g. That's when it becomes a little bit more difficult, and that's what we're focusing on today. Okay? There are some rules up above. You can read those rules. Basically, common sense applies for the most part. Okay? Example 1 was from a previous year's AP exam. Take a second with your neighbor and look at example 1 and do it without me, because you can. Okay? Try example 1, see how you did. Here we go. Show me with your fingers. 1 for A, 2 for B, 3 for C, 4 for D. What do you think? All right. I see 1 right answer. So a little bit tougher than what I thought. I was hoping it would go a little bit better than that. Not quite. That's all right. All right, so we're doing this. The limit as x approaches 5. Up above, you can kind of see the rules here that if we are taking the limits, then it's the same thing as the two limits separated. You don't have to overthink that. Here's what this means, though. Okay, if I want to find this limit, it is the same thing as finding the limit as x approaches 5 of f of negative x plus the limit as x approaches 5 of 3g of x. This is the best way to look at this problem. Let's see what's happening. So if I'm finding the limit as x approaches 5, I need to find the limit as we approach from the left and the right-hand side. So what values are you looking at here to approach? What's a number that's a little bit less than 5? 4.9. And so if I am doing 4.9, I'm then doing the negative of that x. And so I'm really looking at negative 4.9. Okay, negative 4.99. And I need a number a little bit bigger than 5, which would be like 5.01. And so it's really negative 5.01, and so on. So which limit am I really finding as x approaches what value here? I want to approach negative 5. Because of that, it's basically telling you exactly what you want. Oh, the x is 5, oh, make it negative. All right, so I'm finding the limit at negative 5. So if I'm finding the limit at negative 5, I get 4. So this guy right here is 4. Plus, the limit as x approaches 5. Oh, I got a constant right there? Cool, so it's 3 times. What is the limit as x approaches 5 of g of x? It's 5. 4 plus 15, answer is 19. Don't overthink it. Make sure you understand what's happening. Oh, it was a negative x, then make your x value negative. Try it again. Okay, try the next one. Don't get lost with that weird chart there. See what you and your neighbor can do. What is the limit as x approaches 3 of h of x? And so I'm just doing this. The limit as x approaches 3 of h of x. Destiny, what can I put in for the limit as x approaches 3 of h of x? 2. This thing right here. So boom. It's 2 times the next one. It's 2 times f of x. What can I put, Jesse, for the limit as x approaches 3 of f of x? 2, because he wants the limit. So this is 2. Plus 3 times the limit as x approaches 3 of g of x. What are we putting for that? Anybody? 8. 2 times 2 is 4. Plus 3 times 8 is 24. That's 28 times 2. It's 56. Don't make it harder than that. Got a lot of weird answers from some smart people because we're maybe making it too difficult. Don't. So just make sure that you can handle that concept. Let's jump into something else. And so now with equations aren't too bad. It is when you look at graphs that things start to get a little funkier. Okay, because you can't make a function do these things unless you're doing a giant piecewise. Okay, and so these graphs can make it a little bit tougher. Here's the key. If as you find a limit of multiple functions, so like f of x and g of x, if you're doing more than one function and you think the limit is dne, be very confident that the answer is dne. Okay, very often when you think it's dne, it's not. Okay, instead make sure you're examining the limit from each side individually, and if both of those sides are equal, then that limit exists. All right, and so try a real quick without me. See what you can do with a. If I'm finding the limit as x approaches negative 2, Matthew, what's the limit as x approaches negative 2 of f of x? It's 3, because he's going to this graph of f of x. He is walking as we get closer and closer to negative 2. His limit is 3. Then he's going to add to that the limit as x approaches negative 2 of h of x. Sophia, what's the limit as x approaches negative 2 of h of x? Yep, it's negative 1. She's walking on this side. This side, we're getting closer and closer to negative 1. 3 plus negative 1 is 2. Boom, done. Again, don't overthink it. Some of them are easy. Try the next one. Try letter B. Here we go. We're finding the limit as x approaches 1. So if I'm finding the limit as x approaches 1 of h of x, Jacob, what's the limit as x approaches 1 of h of x? 1, because as he approaches both from the left and the right-hand side here, it's 1. So it's 3 times 1 minus 2 times the limit as we approach f of x. So if we do f of x right here, what value is that going to get for us here, Mason? Negative 1.5. Make sure you made it negative. I think a lot of you made it positive. 3 times 1 is 3, minus a negative, so it's really plus 1. It's 4. Yeah, we're good. It's 4. Ha! Take that. It's 4. We good there? Limit as x approaches negative 1. Don't write anything down. Just look at the limit as x approaches negative 1 of f of x and h of x. What happens as you look for the limit? What is the, if I just said, what is the limit as f approaches negative 1, what would you get? Not exist. What about h of x? What would it be? D and E. So at first glance, when you do this problem, you're going to think that the answer is D and E because limits separately were D and E. But that's not true here. If you think that a limit is D and E, then you need to examine it from both sides. All right, and so I did not give you enough space down here, so write kind of small. But we're going to look at the limit as x approaches negative 1 from the left-hand side, just the left-hand side. And then I'm going to look for the limit as x approaches negative 1 from the right-hand side, and I'm going to see if these two limits are equal to each other. Because if they're equal, the limit from the left and the limit from the right are equal to each other, then we're good. We have a limit. So we're doing f of x minus h of x. All right, so let's look at that and see if it's true here. So f of x minus h of x for both of them. So looking at the first one, if I were looking for the limit of f of negative 1 from the left-hand side, Sam, what's that going to be? Left-hand side of negative 1 of f of x. It's 2. Yep, as I walk down this line, I'm getting closer and closer to 2. So this is 2 minus h from the left. Kara, what's h from the left going to get us? H from the left is 1 because we're walking that line. We're getting closer and closer to 1. So 2 minus 1. The limit as we approach this thing from the left is 1. Then we're going to approach it from the right-hand side. Okay, so Abby, if I approach f of x from the right-hand side of negative 1, what am I going to get? That would be 1 because as I walk up that line right there, I'm getting closer and closer to 1. Minus h from the right-hand side. Dylan, what's h from the right-hand side going to be? 0. So it's 1 minus 0. Oh, that's also 1. Since the limit from the left-hand side is equal to the limit from the right-hand side, my limit is 1. It's weird to see because they look like two separate functions. But remember, we're adding them together. And when you add them together, you can get new things. Okay, and that's what's ended up happening here. Use that same mindset and see if you can find the limit on D. Show me with your fingers. What'd you get for letter D? Letter D, we got some turtles here. We got some D and E's. Let's look at it. So if I'm finding the limit as x approaches this thing, okay, if I just tried to find f at 2, oh, that would be negative 1 plus 2. Oh, that's D and E. And so since we got D and E, we can examine that thing from the left and the right-hand side. So if you would like to, you could write this thing out. 2 from the left, 2 from the right. And so if I do it from the left, f of x is going to be negative 1 plus 2 from the left is going to be 1. That gets me 1. But if I do the same thing from the right-hand side, this is going to be negative 1 plus 2 times h from the right is going to be 4. That is 7. 1 is not equal to 7. So even when I break it up left and right, it didn't affect our answer. Kind of makes sense what happened there. Yes, ma'am?
I don't know if I'm going to word this right, but in situations where like one of them isn't D&E, is the some going to be D&E?
So yes, I think you're good with how you said that. And so her question was, if one is D&E and the other one's not, and the sum, then I agree with you. Okay. Now that's not always true if we do multiplication or if we do anything else, but I think if you add and you subtract, that is going to be true. Okay. So good thought process there, and I like your wording. Let's look at the last one here. So the limit as x approaches -2 of this one. Show me with your fingers. What'd you get here? Good. We're getting good numbers here. 3 f of -2. Okay. F of -2. That is 3. H at -2. That is -1. You take all those. You multiply them together. You get -9. Questions there? Let's flip to the backhand side. We're going to keep going. Letter F on the backhand side, just to speed up the process here. Let's do both F and H together. F and H together. I will tell you that F and H have the same answer. So if you're getting a different answer for one of them, double check why. We're finding the limit as x approaches -2. So we're doing this one first here. We're just doing both of them. We're taking g of x divided by h of x. So Grace, what did you find for the limit as x approaches -2 of g of x? It's 5. Yep, good. She's approaching the left and the right-hand side. She gets 5 for that, and she's going to divide it by whatever we found for h of x. Bella, what did you find for as you approach -2 of h of x? You got 1. Yep. This way. It's 1. It's 5 divided by 1. My answer is 5. Nothing tougher than that. There was no D&E, so I didn't have to do anything funky. Let's look at letter H. Letter H, x approaches 3. At first glance, if you look at the limit at 3, we're approaching two different numbers. And so this is D&E. And so we're getting kind of stuck there. Same thing with G and H. They're both D&E at those spots. So instead, I looked at them separately. Jacob, what's the limit as x approaches 3 from the left-hand side of h of x going to get us? H, look at you flipped H and G. 5. It's 5. Yeah, you're good. 5 times, and then G of x is going to be 1 because he's approaching from the left-hand side there. It's 5 times 1. His limit from the left-hand side is 5. If we're going from the right-hand side, Alexander, what's the limit as we approach 3 from the right-hand side of H? Yeah, you guys do G first, but that's okay. Yeah, this number is 5. And then what about the other one? It's 5 and 1. So when we multiply those together, we get 5. Since the left limit and the right-hand limit are the same, we're going to get an actual limit here of 5. Right, good to that point. Now we get into the fun ones. Let's look at letter I and J. Okay, I'm going to skip I. It's fine. I don't think it's the best use of my time. Let's look at J instead. Okay, letter J says the limit as x approaches -2. We have two functions here. This is where we get a little bit funky. Okay, we are doing function composition. One of them is placed inside of the other one. And so it's going to kind of change our rules here a little bit. Be careful with it. And so if we do function composition, how do we always start? Inside out. We're going to start with f of x. And so this problem is really asking us to do this. Find the limit as x approaches -2 of f of x. We're finding the limit as x approaches -2 of f of x. So looking at that board, we're doing f of x, limit of -2. Show me with your fingers. What is that going to be? Looks like 2. So if we go to my graph at -2, I'm walking this way. I'm walking this way. It's 2, but more specifically. Okay, remember, we don't really ever care what happens at 2. Which way are we approaching 2 from? We're approaching it from above. Everybody agree with me? We never actually reached 2. Okay, because we're approaching from above. We're reaching like 2.00001. We're getting really close to 2, but just a little bit bigger than 2. Does that make sense? And so now what we're going to do is we're approaching 2, but we're approaching it from a positive side. We've got numbers a little bit bigger than 2. And so that we need this idea, that plus sign, to help me find the second limit, because we haven't done the g of x. I'm going to take my answer and plug it in. Now I'm finding the limit as x approaches 2 from the right side only of g of x. I'm doing it because my last one was 2 positive, 2 from the right side. So now I'm just doing the limit as x approaches from the right side of 2. So here's 2. I'm doing g of x. I only want to approach it from the right side. So if I approach it from the right side, what number am I getting closer and closer to? 3. It is a function composition. The answer to one directly affects the other one. Okay, so for this first picture, we approached both of them from the top. So since they both came from the top, I really only wanted to look at one number. Okay, I only want to look from the right-hand side. What if I would have done it here? Which side limit would I need it to be equal to then? Both sides. You would need to approach the same value from both sides if I were looking at a spot like that. Okay, and if I looked at a spot here, I would only want to look at numbers less than because they're both coming from below. Does that kind of make sense? That idea is a little bit challenging. Don't let it be too much. Let's try A and B down below, F, G, and H. See what you can do with those. So to do letter A, we're finding the limit. We start with the inside. So we're looking at g of x. We're finding the limit as x approaches 0. So if I'm doing g of x, I'm approaching from the left and the right-hand side. From both the left and the right-hand side of 0, I'm getting 0. Notice that I'm approaching it from both sides. I'm approaching it from above it and below it. And so I need to find an actual limit on the next. It's not a one-sided limit. It is a limit as x approaches 0. But this time I'm using it of h of x. And so if I did that here, I'm doing the limit as h approaches 0 on this graph right here. So I have to approach it from both the left and the right-hand side. Since both of them were approaching 1, our value is 1. Okay, looking at the second one, show me with your fingers what you get for B. Getting some -1s, some 2s, and some 3s. Let's see which one we like here. So we're going to start off with the limit as x approaches 3, and we're going to start with the inside function, which is g of x. So Cami, as we approach g of x and I do the limit at 3, what is the limit as we approach 3 going to be? Good. We're approaching 2, but we're approaching it from the bottom, and so it is similar to 2 from the left-hand side. We're really going to get the answer 1.9999999. So close to 2, we're going to call it 2. All right? And so then we are going to find the limit of the second one as x approaches 2, but we're going to approach it from the left-hand side, and we are doing that of f of x. Okay, so if I'm going f of x, I'm doing 2 from the left-hand side. I should be getting closer and closer to -1 there. So my value is -1. Everybody good there? Let's try C. See what you can do with C here. What'd you find for C? We're getting some 3s, some 2s. Let's see which one it is. So limit as x approaches 0. We're doing the inside first. So the absolute value of x plus 2. We're finding the limit as we approach 0. Okay, think about what that is. Plug in a number. What's a number a little bit less than 0? -0.0001, right? We are finding that limit. We are doing the absolute value of it. So what is the absolute value of -0.001? 0.001 plus 2. So that is 2.001. You agree with me on that? So if you would like to, you could say, oh, when I do that, I got 2.001. And I really just did that from the left-hand side. But what if I went from the right-hand side? If I plugged in a number a little bit bigger than 0. So if I plugged in a number a little bit bigger than 0, like 0.1, well, I would take the absolute value of it, still be 0.1 plus 2. Oh, that is also 2. Okay? But it's 2 from above, because think about what this graph is. This is an absolute value. The plus 2 takes me up 2. As I approach 0 from both sides, I'm getting a number that is closer and closer to 2, but I'm only approaching it from the positive side. I'm only approaching it from above because it's absolute value. All right, so then once I've done that, I'm going to find the limit as x approaches 2 positive of f of x. And so in other words, I'm looking at my f of x graph. I'm going to 2. I'm doing it from the right-hand side. My answer is 3. These are tough questions. Okay, on a scale of 1 to 10, the questions that they're going to throw at you on the AP exam might be a 6, maybe a 7 if they got crazy. I would say that one alone is probably like an 8 or a 9 on the AP exam. Okay, that one's tough. Okay, so if you're doing these problems and you're like, man, I'm really bad at this, I really just need you to be good at part A. If you can be good at part A, you're going to be able to do 80% of what they throw at you. Okay, and so don't be too concerned, and that's probably more than 80%. If you're struggling with C, don't be too distraught by it. Letter D, we get an answer on letter D. I don't know. Have we gotten to D yet? All right, try D and E real quick. Try those two more, and then we'll go from there. I'll show F up here, or D and E. There we go. Looking at letter D. At first glance, if I tried to do f of x plus 2 at 0, if I move to the right 2 on f of x, you would see that there is a break right there. Okay, that would put you at positive 2, so there's a break. So at first glance, it might look like it's D and E. Okay, but we're doing g of x times that. And so if I do g at 0 from the left-hand side, and so g at 0 from the left-hand side, I'm getting closer and closer to 0, times f of x plus 2 from the left-hand side, that's going to be down here at negative 1. So 0 times negative 1. Then we're going to do it from the right-hand side. If I approach it from the right-hand side of g of x, I'm getting closer and closer to 0. And then if I did f of x plus 2, that's approaching this thing from over here. That gets me 3. But since both of them are times 0, it's 0. They're equal to each other. My answer is 0. Makes sense on D. Yes, sir.
If you're answering that problem, you saw that you were multiplying and one of them was 0, could you just say immediately?
You would probably, yeah. These are not going to be free response questions, and so this would be a multiple choice question on the AP exam where you don't have to show any work. And so if you can do this in your brain, good for you. Okay, these are not things we're going to do as much. Okay, letter E. Somebody get an answer or show me with your fingers what'd you get for E. Good, nice job. Letter E is negative 2. Let's look at it. You're finding the limit as x approaches 2. Okay, at first glance, it's going to look like it didn't work, and especially with this concept right here, f of x minus 1. So let's separate the two of them. We're going to find the limit as x approaches 2 from the left, and limit as x approaches 2 from the right. If I do f of 2 from the left, so 2 from the left, that's negative 1 minus 1 squared minus 6. Negative 1 minus 1 is negative 2. Squared is 4 minus 6. That's negative 2. In order for this to work, the other one has to get me the same thing. And so I'm trying to see if this one's going to work. And so limit as x approaches 2 from the right side of f of x. So if I approach 2 from the right side, I'm getting closer and closer to 3. So this is 3 minus 1 squared minus 6. That's 2 squared. It's 4 minus 6. That gets me negative 2. Since both sides are equal to each other, my answer is negative 2. Some challenging questions today. Again, if you're a little bit distraught by it, don't be. Okay, these are the worst case scenario of this. If you've got a little bit of it, you're doing excellent. Okay, don't be too discouraged if at first glance you're not great.